In the last presentation, we looked at ratios and rates, and now we're going to get into the heart of this module, which is proportions. Before we begin this presentation, I am going to allow you to use calculators for this, so if you need to grab your calculator, please do so at this time. So what is a proportion? A proportion is an equation obtained by setting two ratios or rates equal to each other. So let's go ahead and look at a couple of examples just to see what this looks like. So what we have is, for example A, we have 6 feet is to 11 feet as 18 feet is to 33 feet. So our first fraction, our first ratio, is 6 feet is to 11 feet. Remember that with ratios, we do not need to include units, so we can write this as just 6/11. The word as represents our equal sign. And our second ratio is 18 is to 33 feet. So this translates to 18/33. And we're done with this first one. So this is an example that includes ratios. So remember, with ratios, no units. Now we can also do this with rates. So B, we have 9 is to 6 liters as $3 is to 2 liters. This is an example involving rates since we have different units. Remember that when we have different units, we do want to go ahead and include them in our problem. So this is going to be $9 over 6 liters as becomes our equal sign. Our second rate is $3 over 2 liters. Okay, so that's fine and dandy and all. This is not going to be the core of what we're going to talk about. So let's go ahead and look at some other examples. Now you can't just slap two fractions equal to each other and claim that it's a proportion. The main thing is that they do have to be equal. So in order to determine whether something is actually a proportion, we want to make sure that we do one of two things. So in order to determine whether something is a proportion, we have our first method. Our first method, we want to reduce each fraction. If they are equal, then it is a proportion. Otherwise, it is not. So let's go ahead and look at example A. Example A, we have 16/12 equals 28/21. So using this first method, we want to go ahead and simplify the fractions. 16 and 12 are both divisible by 4. So if we simplify the fraction, we get 16/4. 16 divided by 4 is 4, and 12 divided by 4 is 3. For our second fraction, 28 and 21, both are divisible by 7. And if we divide by 7, we get 4/3. Since 4/3 is equal to 4/3, this is a proportion. All right, let's look at one more example. we have 5 over 9 equals 18 over 27. 5 over 9, this fraction is already in lowest terms, so we will go ahead and leave it the same. 18 over 27, I can divide by 9. And if we divide top and bottom by 9, we get 2 over 3. I'm going to put a slash through my equal sign because these are not actually equal to each other. And so what do we say here? This is not a proportion because these fractions are not equal. All right, so that is method 1. Method 2, and this is the one that we really want to put emphasis on, is we want to cross multiply. If the resulting statement is true, it is a proportion, otherwise it is not. Now, one of the benefits of the second method is you can have all sorts of numbers inside your proportions. You can have decimals, you can also have fractions, you can have mixed numbers, and it's a little bit easier to work with rather than trying to reduce the fraction. So let's go ahead and see what cross multiplication looks like. For example C, we have 3/5 equals 12 over 20. So in order to cross multiply, what does that mean? It means I want to multiply in an X pattern. So I'm going to multiply 3 times 20 equals, I'm going to multiply 5 times 12. Okay, if we simplify each one of these, 3 times 20 is equal to 60. 5 times 12 is equal to 60. Since we get a true statement, 60 is equal to 60, this is a proportion. All right, let's go ahead and look at one more. Okay, for our last example, let's look at 2.4 over 6 equals 5 over 12. So for this problem, one thing to note is that we can go ahead and leave the decimals alone and work with them in decimal format. We do not need to rewrite our fraction without decimals because we are cross multiplying. So we're going to go ahead and cross multiply on this. We get 2.4 times 12 is equal to 28.8, and 6 times 5 is 30. 28.8, is it equal to 30? And the answer is no. So this is not a proportion. Okay, so this as well is not going to be a high priority topic. The main thing that we wanted to point out was this idea of cross multiplication because we are going to use it when we talk about solving proportions. So let's go ahead and look at some examples of that. Our procedure for solving proportions. The first thing that we want to do is cross multiply, and then we're going to solve the resulting equation. For example A, we have 16 over x equals 32 over 20. So if we cross multiply, one thing to note, it doesn't matter what order you do this in. I always start with multiplying my variable. So I'm going to multiply x times 32. We get 32x. I'm going to multiply 16 times 20. 16 times 20 is 320. Now I want to solve my resulting equation. So I'm going to divide by 32. And I get x equals 10. So if x is equal to 10, then this is going to be a proportion. If x is anything other than 10, then our fractions are not equal, and it is not a proportion. All right, let's go ahead and look at a couple more. If we look at example B, we have 7 over 12 equals 15 over x. So I'm going to start by cross multiplying. 7 times x is 7x. And 12 times 15 is equal to 180. Okay, if we divide by 7, we get x equals 25.7142. This keeps going. And so we want to round to the nearest hundredth. What digit is in the hundredths place? That is going to be my 1. My 4 tells me to round up or down. Tells me to round down, and so this is going to be 25.71. Okay, let's look at a couple other examples. We have decimals, and again, we can go ahead and work with decimals. We can go ahead and do the exact same thing. So we're going to go ahead and start by cross multiplying. We get 1.5x equals 0.06 times 2 is 1.2. And then if we divide by 1.5, we get x equals 0.8. All right, last example. Let's look at 2.2 over 5 equals 13 over x. If we cross multiply, we get 2.2 times x is 2.2x. 5 times 13 equals 65. And then if we divide by 2.2, we get x equals 29.5454, and it keeps going. Let's go ahead and round this to the nearest hundredth. So what digit is in the hundredths place? We have the 4. The 5 tells me to round up, and so we get x equals 29.54. 5, 5. And that takes care of solving proportions. In the rest of this module, we're going to talk about applications involving proportions. We have lots of applications involving proportions, hence why we have a term called proportional reasoning. So we're going to be applying this not only to word problems, but we're also going to apply this to decimals. And one of the ones we're not going to look at is unit conversions, but you can also apply this to unit conversions. So in the next presentation, we'll look at some basic examples of setting up and solving proportions for application problems. So go ahead, take a quick break, and then I will see you back here in a few minutes.